Right, I want to continue talking about section 5.5 in your note packet. And if you went on to example 4, you've got some more addition and subtraction, multiplication and division to do. So pause the video, go back and do those examples A, B, C, and D, and see what you get. And when you get completed, then run the video and check your answers against my answers. Okay, go ahead and pause and do that. I do want to look at D, however, because on the previous page I only set the problem up. I showed you that you're setting it up as division, but I didn't go back and simplify it. And one of the reasons I looked at that and thought, okay, it's a difficult one because it doesn't factor for us. And so simplifying it, we'd have to go through long division to simplify it, which is a little bit of a chore. This one, when I set up f of x divided by g of x, f of x goes in the numerator as it's on top, g of x goes in the denominator, it's on the bottom. And this one actually simplifies a lot nicer because this trinomial on the top is going to factor this time. So I'm going to take that top and I'm going to factor it, and we did this in chapter 4. So when I factor it, I'm going to get an x minus 6 and an x plus 3 in the numerator. That's what that looks like factored. And in the bottom, this x plus 3 does not factor, doesn't break down anymore, so we leave it as x plus 3. And hopefully you recall from chapter 4 that when we have the same factor in the numerator, this x plus 3 is going to reduce this factor in the denominator of this x plus 3. And the only thing that you have left is the x minus 6. So that would be your answer. You'd say the new function, h of x we'll call it, is equal to x minus 6. Okay, go ahead and make sure you've got those correct. Now, we're going to go on. The second part of this particular section is called composition of functions. Okay, and let's get through the examples on this page. Okay, it says composition of function. The composition of a function f with function g is written f of g of x, where the domain is the set of all x values such that x is in the domain of f of x, g of x, and f of g of x. Okay, it just means that we have to have common domains for them. To evaluate the composition of functions for a given value, always work from the inside out, okay? So for example, it says if you need to evaluate f of g of 2, you first find what's inside. So you go inside the parentheses, you evaluate what g of 2 is, and then you take that value and you're going to evaluate what that is for f of whatever value you got. So let's see what that looks like. It says I want to find g of f of 5. So I'm going to go and I'm going to start on the inside. So the inside of this, the very inside, is f of 5. So f is the function it's telling me to use. Here's the f of x function. So I want to evaluate that at 5. So to do that, I say, well, that's 3 times 5 minus 8. That would be f of 5. This would be 3 times 5 would be 15 minus 8. I get a value of 7. So when I plug 5 into my f of x function, I get a value of 7. Okay, now I'm going to take that and I'm going to apply it. That 7 replaces the f of 5. That's what that value was. So now I'm going to erase my work here because I don't have a lot of room to work. Now I'm going to go find the g function and I'm going to plug in a 7 to it. Here's the g function. So I'm going to say that's equal to 2 times 7 squared. Okay, I've got multiplication and I've got an exponent. We do exponents first. 7 squared is 49. 2 times 49, this is all going to equal 98. Okay, so I would say that g of f of 5 equals 98. Okay, if I go on to the next example here, I want to go start on the very inside, which is g of 5. So you go find your g function and you're going to plug the 5 into it. So g of 5 is going to equal 2 times 5 squared. Again, we square first, so 5 squared is 25. 2 times 25 is equal to 50. So this value is 50, so I'm going to go now and I'm going to take the f of, I'm replacing g of 5 with the value that I just found. It's 50. So now I'm going to find the f function at 50, f of 50. Okay, just to give myself a little room here, here's the f function. So f of 50 is equal to 3 times 50 minus 8. Okay, we multiply before we subtract, so I get 150 minus 8, or a value of 142. Okay, again, we're going to start on the inside here. We're going to evaluate f of 5. I want to find f of 5 first and see what value I get for that. So I find the right function. The reason this is a good point of why they have different names, why one is f of x and one is g of x. If they didn't have different letters, then you wouldn't know which function to plug it into. But I'm going to go to the f function and I'm going to substitute a 5 in there. Okay, so I'm going to get 3 times 5. 3 times 5 is 15 minus 8, that's 7. So now I'm going to evaluate f of 7. Okay, f is on the outside as well, so I'm staying with the same function, but now I'm going to evaluate it at 7. So if I plug that in there, I would have 3 times 7 minus 8. That's 21 minus 8, or 13. So this all has a value of 13. Okay, you can go ahead and give that last one a shot there. Okay, only thing different with the next example is we've changed the functions on you, but you get more practice at this. So f of 3, I'm going to plug into the f of x function. So I'm going to say f of 3 would be 3 squared. 3 squared is 9, so now I'm going to evaluate g of 9. So I'm going to go find the g function. Here's the g function, and I'm going to plug the 9 in. So g of 9 would equal 9 plus 1, or all of this is equal to 10. Okay, I'm going to let you go ahead and evaluate the rest of those. This is going to be 5,000. This one will be 16. This one will be 81. And this one will be 5. Okay, go ahead and check your answers. All right. Says, as with subtraction and division of functions, you need to pay attention to the order of the functions they are composed. This is called composition of functions. So in general, if I take f of g of x, it's not going to be the same as g of f of x because we have a different starting point. Here I would start by evaluating the g of x function and then plugging that value into the f of x. And in this case, I would start with the f of x function and plug that result into the g of x function. So they're not going to be the same. It's very different. This is probably the hardest composition to do because we don't have numbers to work with. Here it says take the g of x function and plug it into f of x. So g of x is x plus 1. I'm going to take that whole thing, that all represents g of x, and I'm going to plug it into the f of x function for the x. So I'm going to say that f of g of x is equal to, if I plug it in for x, I'm going to get x plus 1 quantity squared. So all of this is being plugged in or substituted for the x. So when I square a trinomial, remember that means x plus 1 times x plus 1. So what would I have to use there to simplify? Hopefully you're saying, hey, you got to FOIL that. So first term times first term is x squared. Outside product is going to be a 1x. Inside product, also going to be a 1x. Last term times last term is a 1. So all said and done, I've got x squared plus 2x plus 1. Okay, if I move on to b, it says I'm going to take the f of x function. Okay, here's the f of x function. All of that is the f of x function, and I'm going to substitute into the g of x. So I'm plugging that in for the x. So I'm saying this is going to equal x squared plus 1. Are those things that you can add together? Are they like terms? Okay, they're not. So we're just going to leave our answer just like that. There's really no simplifying to do there. Okay, example C, we're going to take the f of x function, which x squared is the f of x function, and we are going to plug it in for x in the f of x function. So I'm going to plug that quantity in for x. So I'm going to say that equals x squared, and x is being squared. And I would simplify this. I have a power raised to another power. That's going to be x to the fourth. And then lastly, I'm going to put g of x. Well, here's all of this represents g of x. I'm going to plug that into the g of x formula. So I'm plugging all of this in for x. It's going to be x plus 1. So all of that goes in place of the x, and then there's another plus 1. I'm taking all of what I highlighted here, I'm plugging that in just for the x, and then there's a plus 1. I'm going to simplify that and say my answer is x plus 2. So when you're substituting a function into another function, you're going to end up with variables. You just have to make sure you simplify. So if you can add, combine your like terms, or if you're subtracting, whatever you're doing, go ahead and combine your like terms there. Okay, we've got some examples here on the back page. It's just kind of more of the same. You're taking a function and you're plugging it in for a function. So I'm just going to let you go ahead and complete that, and then we'll come back and we'll see how you did. Okay? And that is the end of 5.5.